So now let's see about rules of inference. So what is all about these rules of inference? So inference theory, it says that apart from the laws of implication and equivalence, we have three rules. One is called as rule P, rule T and rule CP. What is this rule P first of all? So rule P is whenever we are in need of getting the conclusion part of the statement, we will be inserting the premises as and when needed, right? We can insert the premises as and when needed, as and when needed. So that we can write it to be as rule P. And what is all about rule T? So rule T is if we are applying the logical laws, that is laws of implication and equivalence, to any of the premises and simplifying, that will be written as rule T. That is here logical law of implication and equivalence will be used. And next rule CP is conditional proof. That is, if we think that any of the premises is missed out, and if we had that premises, definitely we would have arrived at the conclusion part, then it can be added. So added premises will be there, and that will be denoted as rule CP. So this is all with the rules of inferences. That is, we will have rule P, rule T and rule CP. I'll repeat this. Rule P is whenever at the time of derivation we are inserting the premises whenever it is needed, it is denoted as rule P. And rule T is any of the logical laws we are applying it, we will say it to be as rule T. And then rule CP is if we think that if this premises would have been there, definitely we would have got the conclusion. In that case, we can add a new premises. Whenever we are adding a premises in order to get the conclusion, then that will be called as rule CP. That is conditional proof. Now, okay, fine about that. What is all about the inconsistency? Inconsistent, right? Suppose if we are given with the premises, say, or if we are given with the statements P1, P2, so on till Pn. So how do we say that this is an inconsistent statement? So inconsistent statement means whenever we take the conjunction of all these premises, right? So the conjunction, this will imply conjunction of all these premises of all these P1, P2, so on till Pn should give, right, should imply what? Should imply a contradiction. Fine. So consistency means, or sorry, inconsistency means whenever number of statements are given, if we are taking the conjunction of those statements and finally if we are able to get it as a contradiction, then the given argument or the statement is said to be inconsistent. So this we will see in the further examples. So now I hope everybody will be thorough with the rules of inference as well the laws of implication and equivalence. So keeping all in this in our mind, we will have to do the problems. That is, we have here two proofs, method of proofs, right? So two methods. One is called as direct proof, right? Direct proof, and the other one is called as indirect proof, right? Under the rules of inference, we have two proof. First one it is called as direct proof. The second one it is called as an indirect proof. So what is all about direct proof? So direct proof la the premises will be given and we will be supposed to get the conclusion. So we will take all the premises one by one and we will conjunct each of the premises so that we get the conclusion part of the problem. So what is the procedure that we will have to follow? So the procedure says whatever, irrespective of the method. What does this procedure say? The first point is that in the direct proof, right? In the direct, hereafter I will write direct proof to be as dp and indirect proof I will write it to be as idp, right? So in direct proof it should end with the finite number of steps, right? So it should end with the finite number of steps. Finite number of steps. It should end with finite number of steps. And second one is that, second point, so we will be applying the laws of implication and equivalence. Laws of implication and equivalence. Third point is that we should get the conclusion of the problem. This is the procedure in case of a direct proof. So what is all about indirect proof? So indirect proof la, the first and foremost step is that in the indirect proof, the first step is that we will have to take the negation of the conclusion, right? We will have to take the negation of the conclusion as the first and foremost step. And what should we do after that? So whatever procedure we have done for the direct proof, the same procedure can be followed up, and the last step must be a contradiction here, right? So in case of a indirect proof method, first and foremost step is that we will have to take the negation of the conclusion, and the rest of the procedure we will be following it in case what we have done for the direct proof, and the final step is that we should be able to get it as a contradiction. That is what the procedure of direct and indirect method says. So here let us see examples for direct and indirect proof method. So first one is demonstrate that R is a valid inference from P conditional Q, Q conditional R and P. So which means that here either one of the method I can follow, that is I can do by direct or by indirect. First let us do by direct, where we will get familiarized or we will get used to it, and then we will move on to indirect. So all the procedure will be same in case of your indirect. The only thing is that the first and foremost step what we will do is that we will take the negate of the conclusion as the first step, and the last step it must be the conclusion. In between all the steps we do adopt as that we have done for the direct proof. So first is we will do it this way: serial number, statement, and then the explanation part, right? Fine. So here, and also one more thing I would like to stress here. So it is not always that we will be taking the premises one by one in an order. In a random manner also you can take, and then you can get the conclusion. So we will have to just look into the conclusion part, and accordingly we will have to take it. So there are many ways in which one can do it. So first I will take this statement, P conditional Q. See, whenever I am inserting a premises, what should be the explanation made here? It is rule P. That is what the rule of inference says. So now here again, either I may take this or I may take this, nothing wrong in it. I can take any which one I want. So I can take the second one as Q conditional R. So now also I am introducing, I am inserting, so the explanation is rule P. Now what is the suitable law I can apply here? See, first statement ends with Q, second statement starts with Q. So therefore the most appropriate rule I can make here is what? Chain rule. So it is P conditional R, that is chain rule on 1 and 2. So now again I am left out with only one P, that is rule P. Now look at the statement, no? Finally I am able to get the conclusion part as R. I do have P and I have got P conditional R. So if that way I can do, so this is detachment. So I can apply a detachment on 3 and 4, right? On 3 and 4. See, I have P conditional R, this P and P will go and I will get R. That is what my conclusion. Understood? So if you do many problems, then you will be able to understand it in a better way. See, I will repeat again this. I have taken first one P conditional Q, since because I am inserting the premises, I give the explanation as rule P. And next is Q conditional R, again I have taken the premises as it is, so the explanation I am giving here is rule P. Next is, for these two statements I can apply the chain rule, right? Why I am applying the chain rule, that also you must be aware here. Since this statement ends with Q and this statement starts with same Q, so that only I am applying the chain rule. So then I get it to be as P conditional R. Now I am left out with this P, and now if I am introducing that here na, it is rule P, and again I have P comma P conditional R. So the law called as detachment can be applied for these two, and I will be getting it as R. That is what my conclusion. Understood? Okay, fine. So next is here, show that this implies this. Fine. So again, serial number, statement, explanation. So first one, whatever thing we want, we can take it. See, if I take P conditional R na, I cannot do anything with this this term. So something it can be done for this. But whereas see here, no, this statement ends with Q and this statement starts with Q. I can apply chain rule. So I will consider these two. Right. First one, negate P conditional Q. I am inserting here. So the explanation is rule P. And next is I have here Q conditional S. So that is also rule P. And now for these two I can apply chain rule. So chain rule on 1 and 2. So we get this to be as negate P conditional yes. After that, what should I do? So here I have this term, right? So therefore for this we will apply contrapositive. So now everybody should be thorough with the laws, only then you can do, right? Contrapositive is both sign and the direction should be changed here. So this is contrapositive is what? Whenever we have P conditional Q na, this is equivalent in writing negate Q conditional negate P. That way if I write it na, I get it to be as negation is conditional negate of negate will become P. Fine. Now I am left out with this P conditional R. So that is rule P. Then see here, this statement ends with P and this statement starts with P. So I can apply chain rule. So if I apply chain rule, I get it to be as negate S conditional R, right? So here the rule is chain rule I have applied on 4 and 5. So now you just look into the statement and look into the conclusion part. Still we are not able to get a very exact form of the given thing. So that again I will have to apply the contrapositive. We will have to think. So only if we are in a position to think over the given statements, we will be able to arrive. So now if I take the contrapositive, it is both sign as well as the direction should be changed. Negate R conditional yes. So that is what the conclusion part of the problem. Understood now? Yes. And next here, third one, using rules of inference, show that SRR is tautologically implied by P or Q, Q conditional S and P conditional R, which means that from these set of premises, one must be able to get this as the conclusion part, right? So serial number, statement, explanation. Again we will have to just see here, this PQ here I have got, here QS I have got. So now I will take this statement as it is, P or Q. I am inserting it now. What is the explanation? Yes, good. It is rule P. Now what can be done for this? I can apply conditional equivalence. See, whenever if we have to simplify na, if we have the conditional connective, it will be better for us to simplify. So I can have this to be as negate P conditional Q. That is conditional equivalence on 1. So now the next statement we can take Q conditional S, right? That is rule P. And next see here, this statement ends with Q and this statement starts with Q. So what is the rule I can apply for these two? So very good, that is chain rule. So chain rule is negate P conditional S. So chain rule on 2, 1, 3. Chain rule on 2, 1, 3. And now we have taken these two and we are left with only this. But the thing is that I have got here P. So now again I will apply contrapositive. You may ask me why you are applying this contrapositive, that conditional equivalence and so on. So look into the given statement and accordingly you will have to take. See here I will explain why we are taking contrapositive. I have got P conditional here, P conditional R. but then I have got negate P conditional yes. I cannot do anything with these two statements as it is. So if this statement ends with P na, something can be done with this statement. So that is why if I have to end this with P na, I can apply contrapositive. So contrapositive is what? Negate S conditional P. Understood? So now sixth one, I will take that statement as it is. So that is rule P. And now see here, the statement ends with P and the statement starts with P. So therefore, I can apply chain rule here. So if I apply chain rule, I get negate S conditional R. So chain rule is applied here for 5 and 6. So now look into the conclusion part. I have S or R, but then I don't have the connective as R. Instead, I have got here as conditional. If I am supposed to remove that conditional, what should I do? So if I am supposed to remove that now, I will have to apply conditional equivalence. So now everybody should be aware of all the logical laws of implication and equivalence. Only then we can do what? Conditional equivalence. What is that conditional equivalence? If I have P conditional Q, this is equivalent to writing as negate P or Q. Or if I have the other way, negate P conditional Q, if I have, still I can write this to be as P or Q. That way if I write this now, I will get this to be as S or R. See, that is my conclusion part. Understood? Yes. Check the validity of the argument. See, check the validity of the argument. What the question says here, some argument is given and I am supposed to check out whether that given argument is valid or not. Valid in the sense, whatever conclusion is given, I must be able to end up with that conclusion. So if I am not able to get that conclusion, then it is an invalid statement. So for which I will have to read the passage, I will have to identify the keywords. After identifying the keywords, I will have to assign the variables and then I should frame the premises. After that only, I will have to find out whether a given argument is valid or not. See here, if the band could not play rock music or the refreshments were not delivered on time, then the New Year's party would have been cancelled. Fine. So till here, what are all the keywords? Band could not play rock music. Refreshments were not delivered on time. New Year's party would have been cancelled, right? So these are the, in the first statement, 3 keywords I have identified. So let P denote band could not play rock music, right? Band could not play rock music. Q represent refreshments were not delivered on time. Refreshments were not delivered on time. PQR. New Year's party would have been cancelled. New Year party cancelled. Okay. Next is allies would have been angry. That is the next keyword, right? PQRS. Allies angry. If the party were cancelled, okay, the refence would have been made. PQRST. Refence would have been made. Refence made. No refence were made. Therefore, band could play rock music. So now these are all the identified keywords and I have assigned the variables. Now that we will have to frame the premises. If the band could not play rock music, if the band could not play, so that is P. Or refreshments were not delivered on time. Refreshments were not delivered on time is this P or Q. Then New Year's party would have been cancelled. New Year's party would have been cancelled is conditional R. Right? Allies would have been angry. Allies would have been angry is yes. Right? If the party were cancelled is R. Then refence would have been made. Refence would have been made is conditional T. Right? No refence were made. Negate T. Therefore, implies band could play rock music. Band could not play rock music is P. Could play will be negate P. Right? So these are the premises with this we are supposed to prove that is equal to, or that is that will imply negate P. So let us see serial number, statement, explanation. So first thing we will have to check out and we will have to take it out, right? So first one is, I can take these two, right? Negate T, that is rule P, then R conditional T, that is also rule P, and now this is modus tollens I can apply. Modus tollens is what? Whenever we have negate Q and P conditional Q, this will imply negate P, that is modus tollens. So modus tollens on 1 and 2, we get this to be as negate R, right? I have taken these two statements. Now again these two statements I have, right? So that is P or Q conditional R. What is it? Rule P. I am taking the premises, I am inserting it now. So again see here, this is P conditional Q and negate Q. I can apply again modus tollens. So again modus tollens can be applied for 3 and 4. So now what do we get? Negate of P or Q, right? Negate of P or Q or R, right? Understood? Negate of P or Q R, that is negate P. No, sorry, this will not have. Modus tollens is what? Whenever we have negate Q, P conditional Q, that will imply negate P. I have here negate R and R P conditional Q. So I will get only negate of P or Q. So next is I can apply De Morgan's, that is negate P and negate Q. So this or will become and. So here we have applied De Morgan's law on 5. And then conjunctive simplification, either I can have negate P or I can have negate Q, but the answer we will get it as negate P. So conjunctive simplification. On conjunctive simplification of 6, we have the final conclusion as negate P. So this is how we have to get the proof. And the next one, let us see this example. Determine again the validity of the following argument. That is, whenever we are supposed to get the validity of the given argument, we will have to see to that whether we arrive the conclusion part. If we arrive the conclusion, then it is the valid argument, right? My father praises me only if I can be proud of myself. So let P be the statement, my father praises me. Then Q be the statement, I can be proud of myself. Either I do well in sports or I cannot be, okay fine, PQR. I do well in sports. Or I cannot be proud is negate of this. If I study hard, PQRS, I study hard, I cannot do well in sports. Do not do well is negate of this. Therefore, if my father praises me, then I do not study well. Fine, everything is here. Now see to this, my father praises me only if I can be proud of myself, right? If my father praises me, then I'll be proud of myself. If my father praises me, then I'll be proud of myself. So P condition, if and then I get P conditional Q. Either I do well in sports or I cannot be proud of myself. Either this or that. I do well in sports. Well in sports is R, or disjunction I have. I cannot be proud of myself. Proud of myself is Q. Cannot proud is negate of that. Fine. If I study hard. If I study hard, yes. Then I cannot do well in sports. I cannot do well. Cannot do well in sports is negate. Negate R. Therefore, right, if father praises me is P, then I do not study well. I do not study well. Study hard. I do not study well is negate of yes, right? So study well, study hard. Do not study well is this. So now we'll have to get the conclusion part is this. So serial number, statement and explanation. So we'll have to see to that which premises we can take first, right? So now we'll have your P conditional Q. Let me take this P conditional Q as it is. So that is rule P. And again this R or negate Q, that is also rule P. Now that we'll have to apply the logical laws, no? For that what we'll do? So see to that we bring it in terms of a conditional connective, right? So if I have to write conditional, na, I can apply conditional equivalence, and even before I apply conditional equivalence, we can write this to be as what? I can apply commutative law here, right? So commutative property have been applied onto. Fine. So now apply conditional equivalence to this. Conditional equivalence on 3. So I'll get Q conditional R. So understood why I have applied this commutative. You might be wondering why this lady have applied here the commutative. So why I have applied here is that, so if I apply the commutative, the positions will be interchanged, and then again if I apply the conditional equivalence, I get here Q and this ends with Q, so that I can apply the chain rule. So that way you should have a tricky manner you will have to think out. So now I can apply this statement ends with Q, this statement starts with Q. So therefore we can apply chain rule for this. So chain rule on 1 and 4. Fine, we get this statement. Okay. So next is we'll have yes conditional negate R. So that is rule P. And now I have R, I have negate R. So therefore try to bring this negate R to this side. So if this comes to this side, na, contrapositive I can apply. So contrapositive on 6. Contrapositive on 6 I get R conditional negate S. Now look into 5 and 7th statement, na. This ends with R and this starts with R. So therefore I can write this to be as P conditional negate S. So is that your conclusion? Yes, fine. So that is the conclusion part of the problem. Again we are supposed to prove that the following premises are inconsistent. What did I tell you about the inconsistency? So whatever premises may be given, if we conjunct all those premises and finally if it leads us to the contradiction part, that is false, then we say that the given statement is an inconsistent statement. Okay, with that in mind we will do this problem. If Jack misses many classes through illness, so let P denote Jack misses many classes through illness, right? Through illness. PQ, he fails high school. He fails high school. Then if Jack fails high school, that is there, he is uneducated. PQR, he is uneducated. If Jack reads a lot of books, if Jack reads a lot of books, everything pertains to only Jack. So that is why I am not mentioning names anywhere, only at the beginning I have mentioned. Then he is not uneducated. Jack misses many classes through illness and reads a lot of books. Okay, everything, all the keywords we have identified it and we have assigned it with the variables. Now we will just frame the premises. If Jack misses many classes through illness, then Jack misses many classes through illness. P. If and then we have, what should be the connective? Yes, good, we have conditional. He fails his high school. Q. Fine. If Jack fails his high school, Q. Then, if then again, suitable connective is conditional. Then he is uneducated. R. If Jack reads lots of books, F, then he is not uneducated, not R. Jack misses many classes, P, and reads lots of books, and now we have conjunction. and reads lots of books? Yes. So these are the set of premises given, and with this we will have to check out whether this is inconsistent or not. Inconsistent or not. Okay, we will take the serial number, statement, explanation. So P conditional Q. What is that? I am taking the premises as it is and inserted it. So it is rule P. And next, I will not go for this or this. Why is that? I can do something with these two statements. So I will take Q conditional R. So that is rule P. And next is, see here it ends with Q, this starts with Q. So chain rule can be applied here. So chain rule for 1 and 2, it can be applied. And next is, see here we do have P and S. Take it, P and S, it is rule P. And next, conjunctive simplification, either I have P or I have S. So this is conjunctive simplification on 4. Conjunctive simplification on 4. So next, look into this statement. Our intention for inconsistency, we should be able to get it as F. So now look into 3 and 5, P conditional R. So P conditional R will give us what? R, that is detachment. Detachment on 5 and 3, right, on 5 and 3. And next, any statement if you have not taken, you will have to take it, right. So next is, this is left out. Yes conditional negate R, that is rule P. Now look at the statement now, R negate R will go off. So that is modus tollens. So we get negate S, modus tollens on 8, modus tollens on 8 and 7. We get this and this will go off, we get negate S. So now see here all the premises I have taken it, and now look into the statement 6 and 9. So conjunct these two, S and negate S, conjunction of 6 and 9. What is this? This is F, which is contradiction. So therefore the given statement is inconsistent. I am finally able to get the result as contradiction, right. Okay, we will do one more problem and that we will wind it up, and we will see the indirect proof in the next session. Show that E conditional S, S conditional H, A conditional negate H, E and A are inconsistent. So inconsistent again means we will be considering all the premises one by one, we will conjunct it, and finally we see to that whether we get the conclusion as contradiction, right. Serial number, statement, explanation. So first thing I will take it. Again this is E conditional S, rule P. Second one, I need not go for some other thing. So if I take this now, I can do something with these two by chain rule. So S conditional H, again that is rule P. And now see this ends with S and it starts with S. So we can apply chain rule. Chain rule can be applied for 1 and 2. So we get this. Again E and A we have, E and A, E conjunction A, that is rule P. I can apply here the conjunctive simplification, either I will get it as E or I will get it as A. Conjunctive simplification on 4. Now you will have to think over it now. So here I have got E and here I have got E conditional. So detachment, if I apply this and this will go off, I will get here H. Detachment on 5 and 3. Detachment on 5 and 3. So how many premises? 1, 2, 3, 4 premises. Only 3 premises I have taken it. My intention is to get F. So let us see how do we get F. Okay, fine. So next is we will take this A conditional negate H, that is rule P. And now modus tollens we will apply for these two. So if I apply modus tollens, I do get it as negate A, right. Modus tollens on these two. And finally on the 10th step, if I take conjunction of 6 and 9, right, 6 la I have A, conjunction of 6 and 9, which will give me contradiction, right? So here is conjunction of those two, I get it to be as F. I hope you might have a clear-cut idea of how to get the direct proof and the inconsistent part of any given statement. Thank you.